Okay, today the algebra is not complicated. The algebra is not complicated, and the subject matter is not necessarily complicated, but it is new. Okay? Today we're going to talk about two very specific ideas. Number one is one-to-one functions, and number two is what it means to be inverses. So I taught you guys how to add functions, right? Subtract, multiply, divide. Yesterday we learned another operation called, starts with a C, rhymes with opposition. Composition, very good. So now you know composition of functions. Today you're going to do inverse of functions. I'll show you what that is, okay? Before we can talk about functions and their inverses, we have to talk about what it means to be one-to-one. What it means to be one-to-one. Here's what one-to-one means. Every domain corresponds to exactly one range. What does that sound like? Right. So first we define that it's a function, and every range corresponds to exactly one domain. It is on your study guide. I'll be honest, I can't remember if I put it on the test or not. But basically, all you have to do is memorize the definition of a function, which is the top part. The bottom part is almost identical, right? It just switches the domain and range. Yes. Good thought, but not quite. Yep. I'll give you an example. So here's a function that's not one-to-one, that has some higher level exponents to it, okay? Okay. That is not one-to-one. And here's why, okay? If you look at the domain, if I plug in this value right here, say this is -3, do I get out a positive value or a negative value? And I only get out one. So you can see it passes this first part. Every domain corresponds to exactly one range. Well, what test did we use to see if something's a function? Vertical line test. If you want to be a one-to-one function, you also have to pass the horizontal line test. So would everybody agree that if you look at this function, a horizontal line could be represented by the x-axis? So this graph has an output of 0 in how many spots? 4. So if I asked Alexa, for what value does this function have an output of 4, or of 0, you would say, well, which one do you want? Because there's 4 of them. I'll give you guys an example, okay? Okay, Preston and I are playing basketball, okay? At the end of the game, we're on the same team. I'm really good, so is he. We both scored 50 points in a game, okay? We scored 100 between us. Pretty good night, huh? Let's go out and get Dairy Queen. All right, Dairy Queen, me and you. All right, so we both scored 50 points, all right? Is that a function if we both scored 50? Yeah. We both can score the same number of points, can't we? That's okay to have. But let's say the newspaper called us and said, "Hey, I want a picture with the guy who scored 50 points." Well, could you tell for sure who he's talking about? Does he want me or does he want Preston? Obviously he wants me. I'm better looking. But that's beside the point. No, he wants Preston because he's taking pictures of students. Who knows what he wants? We don't know. That's the whole point. So you really can only have one output as well. So Scott first asked the question, does that mean that anything with an exponent is out of the question? No, I'll draw a function that has some crazy exponents to it, and it does pass both the vertical and the horizontal line test. Okay? Maybe not at the end there, I got a little crazy. So that one has curves to it, but it never fully dips back down, does it? Okay? And so that makes it a one-to-one function. So the first one is not one-to-one, second one is one-to-one. Yeah? Okay. Now that we've got one-to-one out of the way, now we need to talk about something else. I'm going to bring you guys back to first grade. 4 plus what equals 0? -4. So what we say, here's what we state. And this is you maybe remember this from a long time ago, like why did it matter then? It matters now. Okay? -4 is the additive inverse of +4. If you take any two additive inverses and add them together, what are you always going to get? 0. Okay? What number do you multiply 5 halves by to get 1? So 5 halves and 2/5 are what we call multiplicative inverses. Any two multiplicative inverses multiplied together will give you 1. So you can see that there's special results at the end, but like here you got a negative instead of a positive. Here you've got a reciprocal. So everything has kind of different inverses. We can't say, well, it's the opposite value or it's the reciprocal. When you talk about an inverse of a function, here's what we're talking about. Here we go. So inverse of a function inverses, here's what happens. The domain becomes the range. And the range becomes the domain. That means x goes to y and y goes to x. So this is the notation that we use. I apologize because it looks like my computer didn't, well, maybe I should have put a space in there. This says f of x and this says f inverse of x. Note to the world, f inverse of x is not 1 over f of x. That's not what that means. That's not what that means at all. Here's what it means. If we have a function y equals 2x minus 4, and we would like to find the inverse, I switch the x and the y values. So what would this equation look like if you switch the x and y values? Now, we always write functions in terms of y being first. That's generally how we write it. You could leave it like this, but we're gonna solve for y. How would you solve for y in this situation? Add 4 over, so we get x plus 4 equals 2y. Then, so x over 2 plus 2 is equal to y. So my inverse is y equals x over 2 plus 2. So these two functions are what we would call inverses of one another. So it's all going to come together now, okay? There's a lot of connections here, okay? This is really cool. How do you think you can tell graphically if two functions are inverses of each other? Over what? They are reflected over the line y equals x. If the x and the y switch, then they should be reflected over that line. Watch, I'll show you. It's really cool. We're going to take out. I'll take out the calculator. If you want to, that's fine. If you don't want to, that's fine. It's up to you. I'm going to type in that 2x minus 4, and then in the middle, I'm going to type in the line y equals x, and I'm going to make it bold because that's what I want to do. And then I'm going to type in 0.5x, or x over 2, plus 2. And I'm going to zoom standard, and when I do, watch what it does. Got my first line, got y equals x, and it takes that other one. Can you tell that it's flipped over the line y equals x? Yeah, it's reflected right over that line. That's pretty cool. And so graphically, you can tell if they're inverses by whether or not they're reflected over that line. We also have a test to see if they're inverses. Bring it back to here, and then they'll all be complete. If I add any two inverses together, I always get 0. If I multiply any two inverses together, I always get. And if you operate two functions on one another, the way that we operate two functions together is we compose them. The result is always going to be x, the element that you plugged in at the beginning. And we have to check it both ways. It's got to work both ways. Okay, so there's like kind of all the groundwork, the notes. Now let's try the examples. So these all say f inverse. Do you see it? F to the negative 1? Like that. So here's the question. If f of 2 is 3, f of 1 is 9, f negative 3 is 8, and f of 4 is 5, and you know the function's 1 to 1, anybody want to guess what f inverse of 8 is? Yes. Here's what it means. This means right here, if I plug in negative 3, what do I get out? 8. What this means is, if I got out 8, what did I plug in to get it? I plugged in negative 3. So an inverse says, well, what did I plug in to get that result? Okay? What do you plug in to get a value of 3? You plug in 2. What do I plug in to get a value of 5? What do I plug in to get a value of 9? So now you're asking yourself the million-dollar question. Why is it x here? Why is it x that it ends up to be? I'll do a very basic demonstration for you, and you'll see exactly why. Let's compose two inverses together. F of f inverse of 8. What is f inverse of 8? What did you plug in to get an output of 8? Negative 3. So this becomes f of negative 3. If you plug in negative 3, what's your output? 8. So you see how you get what you started with? See? And that's exactly what happens here. Whatever you started with, that's what you get out. Just like that. That's why that works. Okay. Let's do the algebra. Let's find a bunch of inverses. We're going to do 4 examples here, and you're done for the day. We'll do the other 4 on Monday. It says find inverses of the following functions. I have f of x equals 2x minus 5, or y equals 2x minus 5. If you want to find the inverse of that, what do? Switch the x and the y. X equals 2y minus 5. Solve for y. How do I solve for y? X plus 5 equals 2y. Right off the 2. X over 2 plus 5 over 2 equals y. You could leave it all over 2, or you could write them both over 2. Either way is fine. That's the inverse. That's it. Piece of cake. Upside down. Chrissa D likes it. So now we got y equals 2 minus x over 3x minus 4. What's my first step? Yep, so x equals 2 minus y over 3y minus 4. Oh boy. Now I've got a rational expression. Any thoughts what to do? Okay. Write it over 1 and cross multiply. We can do that. 2 minus y times 1 is 2 minus y. X times 3y minus 4 is 3xy minus 4x. Ugh. What do you not like about that? Which one of these 4 terms do you not like? Yeah, the 3xy. Ick. Right? We used to solve problems like these back in chapter 1. Do you remember how? We took everything that doesn't have a y and put it on one side. Then we took everything that does have a y and put it on the other side. And then we factored out the y. And when you factor out the y, now the y is isolated. How do I solve that? Divide by 3x plus 1. And when we do that, we get y is equal to 2 plus 4x over 3x plus 1. That's your inverse of your original function. Right? Okay, last 2 problems. But at the beginning, folks, one more time, I just want you to know, what was the first thing we talked about? We talked about being one-to-one. If you have functions that are not one-to-one, you get problems when you find their inverses. Problems come up. So let's try to avoid those problems. That's what I'm going to show you in your next example here. I don't know how that happened. I've got students that are writing on my board. So anyway. All right, let's look at this one. This one's going to be okay. All right, we've got 2 minus 3x to the third, or y equals 2 minus 3x to the third. So you rewrite it to be x equals 2 minus 3y to the third. How do I solve for y? Subtract the 2. Then x minus 2 over negative 3 equals y to the third. Then cube root both sides. And y is equal to the cubed root, then, of x minus 2 over negative 3. Now, do you know your algebra well enough and your graphs well enough to be confident that that is a for sure one-to-one function? Or that one? If you're not confident, try putting it on your graphing calculator. If you don't want to do it, that's fine. I'm going to real quick here. I'm going to type in 2 minus 3x to the third. Typing in the second one is a little bit tricky. I'm going to do double parentheses x minus 2, divide that by negative 3, and I'm going to raise that all to the 1/3 power. And when I graph these, hopefully I will see 2 functions that are reflected over the line x equals y or y equals x. Let's see what we get. What do you think? Are you confident you did the problem correctly then? I am too. Good job. We do problem D. What does that graph look like? That's what everybody does. Looks like that, Mr. Gantz. Yep. How about this? It does one of these things, but it shifted how many units to the right or left? 1 to the left, -1, and then the +4 makes it. So I'm going to graph this. So everybody would agree that that has a coordinate of -1, +4, right? Okay, so here's where you got to do some deep thinking, this last problem. When I do inverses, what happens to the x values? They become the y values, and the y values become the x values. So if this one starts at -1, 4, what do you think its inverse starts at? I bet you're right. I bet it starts at 4, -1. Okay? What's the domain of this function? Can you plug in x values right here? No, only x values that are greater than or equal to -1. So the domain is from -1 to infinity. What's the range of this guy? Can you get all values down here? Only values from 4 on up. So the range is from 4 to infinity. Let's find its inverse and see how those all compare. The inverse, I take and I replace y and x, and I get x equals 4 plus the square root of y plus 1. What to do? Subtract 4. X minus 4 equals square root of y plus 1. Square both sides. X minus 4, quantity squared, equals y plus 1. Subtract the 1. What shape is that? A parabola. What is the vertex of that parabola? 4, -1. Everybody agree the vertex of this is 4, -1? Is that what we thought? It sure is. But watch what happens. You got to get angry at this part, everybody. You got to be, oh no. Do you see the problem? This is the line y equals x. Look, if you take that blue function, the original, and flip it over the line y equals x, do you get that red thing? No, you don't. You only get what part of it, the right or the left? You only get the right. We don't want the left, do we? Here's what happened, everybody. When you did this algebra right here, you don't understand what's happening graphically. But here's what goes on. When we squared both sides, you run the risk. Anytime you square both sides, you run the risk of doing something that you didn't want to do. And when we squared both sides, we created this whole part right here. And we want to get rid of it. And you know how we get rid of it? We restrict the domain. And it's easy. Look at our original domain. The domain of this one becomes what over here? The range. And the range here becomes the domain over here. So, the way we take care of this, there's nothing wrong with this answer right here. It is 99.9% correct. The one problem is we have to restrict the domain. We have to say, we want to use this graph, but we don't want the whole thing. We just want to have a domain from 4 to infinity. We just want to talk about the graph from 4 on over. We don't want everything else. And that's that. So isn't that neat? You know what I like about that scene is like what I like is when we square both sides, it's like, you just like, okay, we're solving for whatever. What's cool is that you end up, graphically, I mean, something pops up that you didn't want to. It's just like you can create stuff that you didn't want. And that's the interesting thing in mathematics, that we just trust our algebra. Well, algebra has some issues to it when we work around stuff. We got to be very careful sometimes. So squaring both sides creates some issues. You want an assignment, don't you? That's what you really want. That's what you want. You guys are like, as soon as you came in, you're like, give me an assignment already. All right. So, your assignment, 2.9, page 236. Somebody wrote all these stars up here. I don't want them right on my board, but they don't listen to me. I don't have control of my classroom. So, 1 through 6, all it is graphs. You're just using the vertical line test and the horizontal line test to see whether or not it's 1-to-1. So those go by really quick. 17 through 19 is just that F inverse of 8, like what is it? Those should be pretty quick too. Then 31 through 47 odd, you'll switch the X and Y and find the inverses. I do have 1 or 2 problems on that from 31 to 47 that are like the last problem we just did, where you got to think about restricting the domain. If you don't get it the first time, that's fine. You might have to look at it a couple times, so on and so forth. Now, I have a good friend, Riley Schultz. You guys know Riley? Riley uttered words that are famous among pre-calculus students. And she said these words. She said, Mr. Gens, every day I'm in class, and I'm doing my notes, and I'm following along, and I get everything that we do. But then I go home, and I can't remember how to do any of it. Anybody ever felt like that? Okay. I understand. I do. And this is the only advice I can give you. People who have worked through those situations are able to work through it in one of 2 ways. Number 1, they do their math with a partner, where they're able to work through it together. And sometimes that will help. Or number 2, as soon as you go home and you start your homework, you turn on the video for that day, and as you're doing your homework, you're following along to the lesson again. And I can't tell you how many times people have said, wow, when I started doing that, I really made more progress on my homework. So, there's my 2 cents. I won't charge you.